Okay, we are in Unit 1, and this is on atomic structure and properties. So you've got your calendar here. Make note that about 30 minutes a night you need to be working on just chemistry, no distractions, and working through your materials. So make sure you're paying attention to those due dates. We do have a 3-day weekend to start, so that's a good opportunity to get a little bit ahead and work through your things. So your first deadline is the 6th, which is, I believe, next Friday. Let me just check. Yeah, next Friday. So we need to have these first ones done next Friday, along with, and then on Friday, we'll hopefully be doing that first lab. Okay? I want to go over, just taking a minute, these are your objective sheets, as talked about before, but just to review some of the stuff from honors chemistry, if you forgot how to do some of these things, here's a little reminder. So for this first part, we're looking at the number of each type of atom in each formula. So you're listing the different types of elements, and then you're saying how many of that element there are in the chemical. So for instance, the second one, we've got 1 copper, 1 sulfur, and 4 oxygen. Remember, when it has parentheses, the number on the outside applies to both elements, so you distribute it and multiply it through. Okay. For the second part, we're determining the molar mass. So let's talk about what that means. Molar mass is the mass of 1 mole of a chemical. So a mole is a way to count our substances, to count how much of a chemical we have. Sorry, I'm grabbing my periodic table. So, and our equation sheet. So let's review that. A mole is listed here. It is Avogadro's number. So if I have a mole of something, 1 mole of something, it is equal to 6.022 times 10 to the 23rd things. Okay? So for instance, if I have a mole of donuts, I have this many donuts, 602 hexillion. If I have a mole of electrons, I have this many electrons. Okay? It's just like a dozen. If I had a dozen donuts, I'd have 12 donuts. So it's a counting unit. So when you see this mole to the -1, it means per mole. So another way we'd write that is 6.022 times 10 to the 23rd per 1 mole. Okay, so your units on this number would be whatever you're counting, like electrons. So we don't want to actually count substances, though. It's really hard to do that and use them in a chemical reaction. So instead of counting the number of atoms, we measure moles by their mass. So molar mass, the mass of 1 mole. So we notice the units are grams per mole, so it's the number of grams per 1 mole, or in 1 mole of that chemical. And we find those values on our periodic table. So the molar mass of every element is given on the periodic table. It's your number at the bottom of the block. And so if we were to find zinc, zinc's molar mass would be 65.38. When we write it, we would write its units as grams per mole. So what does that mean? If I want 1 mole of zinc, I'm going to go to a balance and I'm going to measure out 65.38 grams of zinc. That means I have 1 mole. And that means I have 6.022 times 10 to the 23rd atoms of zinc in that chunk. Okay. Now, if we have a larger chemical, one with multiple elements, we can still find its molar mass. This one has 1 copper and 2 chlorine in it. We're going to multiply that by its mass on the periodic table. So copper is 63.55 grams per mole. And chlorine is 35.45 grams per mole. We would multiply each of those. 0.55. And, this should be 70.90. I knew there was a 90 in there somewhere. Grams per mole. All right, a little mistake there. And then once we have the total for each element, we're going to add them together. So we end up with 134.45 grams per mole. So that's how we would find the molar mass of something. If you've got an element in multiple places, make sure you add up the total of them. This one's a little bit different. This is called a hydrate. This is called pentahydrate because penta means 5. So the way we would look at this is saying that for every 1 copper sulfate, there are 5 water molecules. So it's like you have your copper sulfate like ions, and then they're surrounded by 5 water molecules. Okay, so for every 1 copper sulfate, there's 5 water molecules. It's giving a ratio. So to find this one, you'd find your copper sulfate like you did here. You'd find water like we did over here and multiply by 5, so you'd really have 10 hydrogens and 5 oxygens, and then add all that together. Okay. All right. Now for the other parts, we're using our molar masses to convert. So because our units are grams per mole, it's a relationship there, so we can use it to convert between grams and moles. So if we are given grams, whatever our given number is, we're going to write down first. I'm going to write that decimal because that's going to make that 0 significant. And I want to change from grams of silicon dioxide to moles of silicon dioxide. Okay. So when we do this, again, we want to use our molar mass. So we're going to find the molar mass of SiO2. So my silicon's mass from my periodic table is 28.09. And then I have 2 oxygens that are a mass of 16. So I'm going to put that in and add it up, 60.09. So the units again are grams per mole. So I'm going to say 60.09 grams in 1 mole. So the 1 goes next to the moles every time. And then we're going to do the math. 120 divided by 60.09. And I get that. Now I'm going to show you something else in your calculator really quick. So I did this calculation and had that mass in there. If I don't want to have to type that again, I could say 120 divided by, hit the second button, and then the negative says ANS above that. That means answer. So it's your previous answer. And it'll put in that 60.09 for you. So just a quick little use of your calculator. That's a great button. So we get 1.997. Let's check our sig figs. We're only going to base it off that given value. You have 3 significant figures there. So our answer gets 3. So I got 1, 2, 3. The 9 bumps up, which also bumps. So we're really, if we think about it, we're rounding 1.99 to 200, or to 2.0, not 200, 2.00. And then our units, grams, cancel, and we have moles of SiO2. As you do this stuff, you should have units and chemicals for everything. Okay, number, unit, chemical. If it's in scientific notation, do not stop, do not pause. Set it up exactly the same way. Okay, all it does is change how you put it in your calculator, right? So when I start to type this in, my setup is going to be the same. I'm just going to type in 1.3 E3 and move on from there with the rest of my calculation. Okay, so don't let scientific notation stop you. Down at the bottom, we're doing the opposite. We're going from moles to grams. If we want to do that, again, we write down our given amount, moles of titanium dioxide, number, unit, chemical, bring down my units, moles of titanium dioxide, and I want grams. So again, I'm going to find the molar mass of that because I need that relationship between grams and moles. So titanium's mass is 47.87 plus 2 oxygen atoms, and we get 79.87. Now again, your units on that are grams per mole. So the number of grams that we calculated per 1 mole. And we can go ahead and calculate. So I'm going to do that trick again. I've got this number. We're multiplying now, so I can just hit times 5.2, and I get 415.324. Let's check our sig figs. We have 2 significant figures in our given, so I want 2 in my answer. Now, we've got 415. I'm going to round that to 420. I'm not going to put a decimal because I don't want that 0 to count. Grams of titanium dioxide. Because our moles cancel. On the last part, it is, I believe, mixed practice. Yes, mixed practice between gram and mole conversions. So we want to just pay attention to what they're asking for. This is a very ugly chemical to find the molar mass of. You might do that on the side there, being careful of all your little subscripts, making sure they get multiplied through. Okay, so be careful on that one. So that's your honors chem review. You will have a quick little mastery check on that one, and then we'll get into the rest of the unit. All right, thanks guys.